All right, we're gonna do number 16. Always, always, always take out the GCF. Guess what? We have 18, 12, 48. I know that 2 goes into each of them, but is there a bigger number? Yeah, I think 6 goes into all of them. And there's a cubed, a squared, and then a, so I can take out one of the a's. So 6a times, each of these terms should be divided by 6a, so 18a squared divided by 6a is 3a squared. Sorry, 18a cubed divided by 6a is 3a squared, plus 2a minus 6a times what gives me negative 48a? It's negative 8. All right, so we have 3 terms again, but this time a is not 1. Trinomial, but a is not 1. So my favorite method is the crisscross method. If you prefer other methods or want to look into others, there are some on my YouTube channel just about factoring. So anyways, under the first term, I'm going to put 2 factors. Under the third term, I'm going to put 2 factors. And then I'm going to crisscross to make sure that those factors really do make up the middle term. So whatever they do, they need to add up to give me positive 2a. All right. So those factors are 3a times a. That one's easy because there's no other option for that. Now, I take a look at the negative. I know that one of that if we're multiplying to get a negative, one of these signs needs to be positive, one needs to be negative. And so just keep that in mind. The bigger result over here needs to be this sign. Okay, so the bigger multiplication over here needs to be positive. So we'll take a look at that, and it should be pretty obvious. So if I chose 1 and 8, I would be multiplying 8 times 3, and that would be 24 and 1. That's crazy. If I chose 8 and 1, 8 and 3, so it doesn't get me 2. So it looks like I need to choose 2 and 4. I'm going to put the 4 first and the 2 second. I know one of them is negative, but wait till we do the crisscross to find that out. 3a times 2 is 6a. A times 4 is 4a. 4a, 6a, that can get us 2a because we know that one of them is already negative, and it is 6a that is negative. And the 6 was the result of 3 times 2. 3 already has a positive in front. We can't change the sign of that. So the 2 needs to be the negative. We take this negative sign and put it over here, which means if this is positive 4a, that positive goes there. And as we write our final complete factorization, of course, drop the 6a, and then you have top row, 3a plus 4, and then times bottom row, a minus 2. Check just to make sure there's no cubes or squares or anything, and then you're done. Number 18 looks so scary. Well, where do we start? Always, always, always take out the GCF. Greatest common factor looks like it's 12 to me. 12 goes into 36, 12 goes into 144. And there's an m in common, so I'm going to take out a 12m. 36m squared divided by 12m is 3m. Negative 144m divided by 12m is negative 12. There's a bigger number that goes into these? You know what? I just made a mistake, and this is really, really good to see. This is great to witness. I, of course, did this on purpose. Okay. See how 3 can go into 12? That's how I know already we did not take out the biggest number. Okay? Because if there's still a common factor, like 3 goes into 3 and 12, if there's still a common factor, we're not done. So you can redo the problem, or you can take it out now. I would just probably redo the problem, but we'll just I'll just cross it off, and then we'll see what other numbers. Okay, but knowing that if I had taken out the 3 times 12 would be, that's the actual GCF. And let's test it. Let's just be sure. 144 divided by 36. Yes, so 36 does go into 144 evenly 4 times. All right, so I'm not going to take out a 12M. I'm going to actually take out a 36M. But when I saw that, that's how I automatically knew that I hadn't factored completely, and that can help you catch any mistakes sometimes. So 36M, so this is just M minus 4. Wow. Okay, and you're done. Ew, what is this? And it's an equation, and we need to solve by factoring. All right, if we're gonna solve by factoring, then we're gonna be using the zero product property, and we can't use the zero product property unless everything actually equals 0. So we have to get everything onto the same side first. Very crucial. Do I move the 3v squared or do I move the 2v squared? You do not want your squared term to be negative. It's not the end of the world, it's just an added step of work. So, and a lot more room for error. So try to just put them all on the same side where the squared term will be positive. Okay, so I'm gonna subtract the 2v squared, because if I subtract that, I know that the v squared over here will be positive. So I'm going to subtract 7v. I'm going to draw the kind of the line down my equal sign. 7 minus 7v and minus 2v squared, if you don't mind, in the same step. So negative 2v squared I'm going to put under the squared term because those are like terms. In the negative 7v, I'm going to put under the 5v because those are like terms. That's 0 on the right side, which was the goal. So 3v squared minus 2v squared is v squared. 5v minus 7v is negative 2v. And then the negative 24, don't forget, is still there. All right, now, is there a GCF? When A is 1, there is not a GCF. So the next thing to check is, that's a trinomial, and we already know A is 1. So we're going to use the P's and Q's method. Two things need to multiply to give me negative 24. Those same two numbers need to add to give me negative 2. So if it's multiplying to give me a negative, I know one of those is positive and one is negative. One is positive, one is negative. And to result in a negative 2, the bigger one has to be negative. So let's do negative 6 and positive 4. Negative 6 times positive 4 is negative 24. Negative 6 plus 4 is negative 2. But you're not done because you have an equal sign, so you use the zero product property to solve. If something times something is 0, then each of these we can make separately equal 0 and solve to get our two answers. V equals negative 4 and positive 6. All right. Wait, this looks different. Doesn't equal 0? Yes, it does. Then we can jump into the factoring. What do we always do first? Take out the GCF. Well, that's 5n. So I'm left with n plus 5 equals 0. Can you factor this further? No. You've already factored it completely. So use the zero product property to solve. Okay, you can put parentheses around this if that makes you feel better, if it's kind of hard to see that wherever you have a variable, that's what you make equal to 0. So 5n equals 0, divide both sides by 5, n equals 0. That can be a solution. 0 can be an answer. Okay, n plus 5 equals 0. Subtract 5, n equals negative 5. So those are my two answers. It can look like this. So when you have if a variable is a part of your GCF, then 0 will always be an answer when a variable is a part of your GCF. But if you just take out a number, it does not affect the answer. It just helps you get to the answer faster. And the last one I'm going to do is 24. All right. Again, I want this all to equal 0, so I can use zero product property. First step. Is there a GCF? Yes, definitely 2. 4 goes into both of these as well. So take out a 4. And you're left with 9n squared minus 4 equals 0. There's something special in here. 9 is a perfect square. N squared is a perfect square. 4 is a perfect square, and subtraction means difference. So what type is this difference of perfect squares, and how do we factor that a plus b, a minus b? In the first part, we put the square root of the first term, so 3n and 3n. Square root of the last term, 2 and 2, positive 2 and negative 2. You're not done. You do have to solve this. Only the ones over here, though. Don't try solving the other ones, okay? It'll waste your time. Only when there's an equation do we actually get an answer. So 3n plus 2 equals 0. And then 3n minus 2 equals 0. So we subtract 2 on both sides. 3n equals negative 2. When you divide both sides by 3 for this one, you get x equals negative 2/3. And then here we add 2 to both sides. 3n equals 2. Divide by 3. And you get positive 2/3. You don't need to put the plus sign in front of it. Positive 2/3, negative 2/3. All right, hope that helps. Happy reviewing.